Hi. During this laboratory practical, Marta and Joele will prepare three naturally occurring pH indicators using red cabbage, blueberries and black beans.
Hi guys, I'm Joele.
And I'm Marta.
So, we will prepare the first pH indicator using some red cabbage. This vegetable's peculiarly intense color is due to its high content of water-soluble substances called anthocyanins.
These are among the most important pigment groups existing in vegetables, and their color varies from red to blue depending on the pH existing in the vegetable.
To do this experiment, we need
A laboratory hot plate, 2 beakers, a glass stirring rod, a filter, a conical flask, and distilled water in a wash bottle.
So firstly, the red cabbage leaves are chopped and then placed in the baker. So a few milliliters of distilled water are added to the pot. This is brought to a boil on a hot plate. The mixture is brought to a boil and then left to cool. We will use blueberries to prepare the second pH indicator. To do this, we will use
A pestle and a mortar, 2 beakers, a filter, a conical flask, and a distilled water in a wash bottle.
the blueberries are placed in the mortar and then ground to a pulp using the pestle. Then a few milliliters of distilled water are added to favor the extraction. So having prepared a sufficiently liquid solution, we proceed with the filtration to separate the solids from the liquids. Finally, we pour the filtered solution in a conical flask and we label the flask with the name of the substance used. The blueberries are being filtered, so we are separating the solids from the liquids from the pulp. Finally, we pour the filtered solution in a conical flask and apply a label with the name of the substance used. We will use black beans to prepare the third and the final pH indicator. To do this, we have
A beaker, a glass stirring rod, a conical flask, a filter, and distilled water in a wash bottle.
distilled water is added. Then the mixture is left to rest approximately 4 hours. Finally, we pour the filtered solution in a conical flask and we label the flask with the name of the substance used. We have prepared the 3 natural indicators:
Blueberries,
black beans.
red cabbage.
Now we will use some household solutions.
Vinegar, ammonia, lemon juice, baking soda, and soap.
These products will be tested using the 3 natural indicators previously prepared. To do this, we will prepare 3 samples of each of them. Now we will create a color chart with the different pH indicators previously prepared. We will mix them with different solutions which have different pH values, and we will start with the red cabbage. Using a Pasteur pipette, we add in each flask some drops of red cabbage based natural indicator. So starting from pH 3, we can see that the color is different, and this because each solution has a different pH level. We keep pouring the pH indicator in the flasks number 6, 7, 8 and 9. And finally we pour the pH indicator in the last flasks. As you can see, the color is different, very different from the first flasks we used before. Now we will test the pH of the household solutions with the red cabbage pH indicator. To do this, we will pour some drops of a pH indicator in each flask. We can notice that the color of each solution changes when we pour some drops of the pH indicator. We can use the solutions with a known pH to determine the pH of the previously prepared household products through a simple visual comparison. We can notice that the lemon and the vinegar solutions have an acid level of pH, while the soap solution has a neutral level of pH. Instead, baking soda and ammonia have a very different level of pH, and so they have a different color. They have a basic level of pH. We've created another color chart using the blueberries pH indicator, and we will test again the household solutions. As we saw before, even with different colors, we can see that the level of pH in each solution is similar to the previous ones. So, as before, we see that the lemon and the vinegar solutions have a very acid level of pH, while the liquid soap has a neutral level. Instead, baking soda and ammonia have a very high value of pH, resulting in a basic solution. As we've done before, we've created a color chart with the pH indicator based on black beans. And so now we will compare the household solutions with the pH indicator with the non-pH substances. We start with the lemon solution, and then we proceed with the vinegar, which have a very high acid level of pH. Then the soap, which has a neutral level of pH, and finally with the baking soda and ammonia solutions.